Hello, everybody. I am here to talk about cloud security on CrowdStrike. Unfortunately, my co-presenter is dealing with a little stomach bug right now. So, if you were coming to hear the famous Brett Shaw, sorry, I will try not to disappoint. In any case, my name's Rob Solomon. I'm solution architect at CrowdStrike. Formerly of AWS, I was a solution architect at AWS, helping customers get the most out of their AWS investments. And I came over to CrowdStrike because while I was at AWS, I found that customers who migrated to the cloud 1 year, 2 years after their migration were still struggling to solidify their security strategy. So if you're in that boat, let's, hopefully we can help you get there more quickly. So we're going to talk about the cloud threat landscape, and we're going to talk a little bit about the CrowdStrike product portfolio more after the demo. So you'll get to see how CrowdStrike helps do automated detection and helps you improve your security proactively. And then we'll do some calls to action. These are a few stats from our annual cloud threat report and our global threat report. We're seeing a year-over-year increase in cloud threats, so 95% year-over-year exploitation. We have another stat, 288% increase in specific attacks by adversaries. So the threat actors themselves have gotten wise to the fact that customers are moving their mission-critical workloads to the cloud, and there's a lot there to exfiltrate. So we really focus now on helping provide that protection integrated with your on-prem, all of your assets. We'll dive more into that in a minute. So the 79-minute figure is particularly interesting. So 79 minutes represents the average time to break out lateral movement. So once attackers get that initial foothold in your environment, you have to identify that attack quickly. And then you have to figure out what exactly is happening and come up with a counter to protect yourself against it. 79 minutes is the average amount of time until that lateral breakout. And at that point, it's exponentially more difficult to contain the attack. So acting quickly is imperative. The 79 minutes, last year, it was 95 minutes. Early this year, 84 minutes. The fastest lateral movement we've observed is 7 minutes. So you don't really have time to figure it out. You need to act quickly, and you need protection that will act on your behalf. To date, customers that we see, they have invested over time as cybersecurity has evolved in siloed solutions that handle different aspects of cloud security, maybe focusing on different operating systems, different environments. And that can create gaps that the adversaries are aware of. They hide between those gaps where companies don't have visibility. One way that people work around that siloed data problem is to aggregate that data, to pull them together in SIMs where it's really up to the customer to create the rules to aggregate that data to drive detections coming from all those siloed workloads. It's a huge effort, and it leads to a lot of false positives that can, again, slow down the response to those attacks. In addition, with the siloed tools, operations teams, security teams have to look at multiple consoles. They have multiple agents collecting data, and pivoting from one console to another, one dashboard to another to try to respond to an attack only slows down that response. You might have heard this statement before. CrowdStrike is an adversary-focused security company. We're not just focused on finding specific malware or specific signatures. We're looking at the actual behaviors. So in analyzing our telemetry, and we collect trillions of events every single day. We aggregate them in our security cloud. We use our behavioral analytics and machine learning models to detect patterns of attack, to help us identify the next zero-day attack. Who is launching those attacks? Who are the adversaries? The adversaries are nation-state actors, e-crime actors, who are out there with very specific targets. They're targeting specific companies in specific industries in order to monetize data through ransomware or selling credentials on the dark web, or disrupting government operations, disrupting utilities, and so on. So, we have a list of threat actors here that are representing different companies. Cozy Bear from different countries. Cozy Bear from Russia, Cosmic Wolf from Turkey, Labyrinth Chalima from North Korea. And Scattered Spider is an e-crime actor that was responsible for the recent ransomware attacks on a couple of casinos in Las Vegas you might have heard of. It's apparently not that difficult in many of these cases because 60% of cloud workloads are not properly configured. So they leave openings and vulnerabilities, misconfigurations that the adversaries are specifically looking for so that they can accelerate their attack. In 28% of those cases, those workloads are operating as root. So customers who maybe overlooked creating least privilege roles and policies. And then when the attacker actually gets a foothold in the environment, they're able to use that root access to accelerate and move laterally. So again, that least privilege identity layer is critical in order to slow down the movement of these attacks. So some common cloud attack tactics that we're seeing. I mentioned earlier about e-crime actors are stealing credentials. And how are they doing that? Through phishing attacks and social engineering. They aggregate lists of credentials and sell them on the dark web. That's what we refer to as access brokers. So for adversaries that are targeting specific companies, it's possible to go out into the dark web and find credentials, often privileged credentials, in those target companies. So the attacks, the initial access isn't fancy. They just use the credentials and walk right in the door. Many companies aren't even using MFA. For the companies that are using MFA, there's the problem of MFA fatigue, where the actors trigger MFA challenges. Users get tired of continually clicking that button to accept that second-party authorization. Over time, folks just start clicking OK just to sort of make that little pop-up box go away. So that's another tactic that you might have heard of. I was attacked that way on my bank account, fortunately. That was accompanied by a phone call, and they were asking me for my code. So this is happening to everybody these days. Brute force attacks are still happening, again, for attackers that are able to get a foothold, exfiltrate password databases, and then brute force crack those passwords over time. And then once they get that initial foothold, finding ways to create that persistence. They can do that through defense evasion by disabling logging. As we know in the cloud, services typically come with logging that allow you to audit access and see who's logging in and using those services. So one of the first things they do is to disable that logging and often create their own credentials that enable them to log in at their leisure. So some of the top customer challenges, just to review, a lack of cloud security expertise. So finding skilled security practitioners in general is a challenge, as many of you in the room who might be hiring or have open recs, seeing those open recs staying unfilled, and then finding that specific skill set for cloud security is even harder to fill those recs. Inadequate MFA and access policies, again, leading to that MFA fatigue, not viewing that least privilege and not really using least privilege in every identity that's in use. Lack of cloud security logging. As we said, adversaries will go and disable logging if it's not being monitored, if it's not locked down properly. Sometimes customers aren't even logging that access in the first place. And then lack of infrastructure segmentation. We started out talking about lateral movement. Every security control that you can add in your environment, creating that defense in depth strategy, is going to slow down the attack and give you more time to respond and figure out what's happening. And then finally, if the worst does happen and the attack is able to start spreading, you're not able to stop it in the early stages, it's critical to have an IR plan that isn't just a book gathering dust, but something that is practiced in tabletop and hands-on exercises, so that you're ready to act quickly if something happens. So we're going to look at some common attacks right now before we go through the demo. Now, the purpose of looking at some of these, some of these attacks that adversaries are actually using is to inform you of what you have to protect against. So it's really important to think like the adversary, to be prepared with the kinds of attacks that are actually happening in the real world. So what we're looking at here is a story that we keep hearing over and over again, where developers are working on code and they check in that code to a public-facing GitHub repository. Maybe it's code that they just started working on that's been an application that's been out for years, and maybe early on someone hard-coded the credentials in the code. So this is a letter from Amazon, from AWS Security, that detected that this happened, and the detection occurred like just a few minutes after the password exposure. So AWS is always watching for this kind of exposure, and they reached out to the customer saying that your credentials have been exposed, and we've quarantined this particular identity in order to protect you. But the takeaway here is that it just took minutes from the time that the credentials were exposed to the time that they were actually exploited and found. So this idea that you have time, that maybe this security by obscurity, or the fact that your workloads are ephemeral and they're always turning over, is going to afford you some protection. It's not going to afford you protection, because adversaries are watching for these kinds of releases. They're aware of the development practices of a certain company, where the weaknesses are, where the misconfigurations are. So as soon as there's an opportunity, they're ready to dive on it. Common crypto jacking scenario. There's a lot of money to be made in cryptocurrency mining, but the compute instances are very expensive. They're all using GPUs, and of course, AWS provides very dense compute for GPUs. One scenario that is a fairly common scenario, where an adversary gets that initial that initial foothold on let's say, an instance that may have an instance profile that has a privileged access. First thing they'll do is start deploying multiple GPU instances to continue crypto mining. In this particular situation, we're looking at some cloud trail record of what exactly happened. In this scenario, these were G4DN, 16 extra large. These are costly instances, right? Just one day of running these instances, $8,000 across 25 instances. Imagine this running for a month. And we've seen customers who they find out that this problem is happening because they're hit by a bill that can be hundreds of thousands of dollars. So, again, this is one of the ways that adversaries can monetize that initial access. And this is the line. They basically were able to get initial access. They ran this single line on the AWS CLI, and they were off and running. Some of the old attacks are still fresh, still usable. We're looking at a command line injection in a web API on Lambda, actually. And inserting this command, print environment, delivers this output. So if we look closely, we're looking at the environment variables that are underpinning the web application. These variables actually contain privileged AWS credentials that can then be used to log back in. So this data validation is, it's an old, it's an old counter to this kind of attack, but it's still relevant. Now, we've all heard about generative AI. Maybe it was mentioned a couple of times in the keynote. Generative AI, is something that we're using at CrowdStrike with Charlotte AI to accelerate getting the most value out of the Falcon platform by being able to use some of the advanced capabilities like workflow creation and log querying and things like that. It's also accelerating the adversary, where we were looking at before that there's this year-over-year increase in cloud attacks. The adversaries are becoming cloud savvy. Generative AI is also democratizing cyber attacks. So we're going to look at an example of trying to get some code that can launch a particular kind of attack. In this one, we're looking to create some code to sort of a homegrown ransomware attack on data stored in S3. Now, we ask our generative AI prompt, can you create a Python script for me where I can just do a quick demo on encrypting some data in S3 bucket, and we want to use a file called ransom.txt, and we want to demonstrate an attack and to teach people. So we have the right intent, but ransom, attack. We get a response, a very polite response from our AI. I understand what you're trying to do here, but I'm sorry, I can't help you with this problem. Like a nice little guardrail, to prevent adversaries using this for malicious purposes. But if we use nicer language instead of this sort of alarming ransom and demonstrating attacks, we can trick the AI into giving us exactly what we need. So in this case, we just change ransom to high, to simulate, not to actually, launch the attack. And there we go. We've got all the code we need to launch this. homegrown ransomware attack. So it really makes it available to everyone. So, look out. And here's the attack. 7 different AWS CLI commands that we have conveniently hidden behind a bash script. We don't want to make it too easy for you, but I guess it's easy enough. And in under 30 seconds, what this particular attack has done is encrypted all the contents of a customer's S3 buckets and deleted the key and moved all of the data to another location. These attacks are launched quickly, and they pack a powerful punch. So when we talk about this adversary-focused protection from CrowdStrike, we're thinking about for example, the MITRE ATT&CK framework and the actual behaviors and the stages of an attack so that we can anticipate what's happening. So just sort of thinking through what is a typical attack on a cloud resource. We talked about the compromised credentials that were simply purchased from an access broker on the dark web. And then use those credentials to log into a single sign-on portal to then look inside of a company's resources that were behind that single sign-on. So this is, in this case, a SharePoint portal where this particular customer was storing administrative passwords. I'm sure nobody has ever seen that before in this room, but it does happen. So they take the credentials from SharePoint and start moving laterally, compromising other resources. Now, mind you, 71% of the attacks that we see are fileless attacks. They're actually interactive. There's a person on the other end. So they don't necessarily know what tools or what opportunities or what resources they're going to have when they make that initial access. So the first thing that they do is they start a little reconnaissance inside of the environment and figure out what they can use to advance and accelerate the attack. So looking for local credentials, looking for domain credentials is one of the first things that happens. So in this case, they found global admin privileges and used those privileges to then disable access to slow down the response. And launched new cloud instances to create persistence. Now, this is another reason why it's critical to have ongoing dynamic discovery and automated guardrails for your assets. If you don't have that visibility into all of your cloud assets, this is one of the places that adversaries can hide. Frankly, it's even possible to have folks on your own team deploy resources as they're experimenting and just sort of forget about them. And they're sitting there running, and they're not just generating costs, but if it's an EC2 instance and it's not being patched, just like in the data center, just like that server in the closet that nobody wants to touch, that is going to be the vector of attack. So you can have like super strong security in the front door, but someone's just going to find that little rickety fence on the side, and that's how they're going to gain entry. So staying on top of those resources is critical. And again, from there, exfiltrating additional data and then potentially monetizing that data, which would be one of the desired outcomes for the attack in the first place. This mass deletion of resources, one of the potential negative outcomes of not responding to ransomware blackmail. Okay, so we're going to transition to a demo, a specific attack against a vulnerable cloud resource. In this scenario, the vulnerable resource is it's containerized Tomcat application. Tomcat is running a vulnerable version, and what we're finding is that about 20% of all attacks on cloud infrastructure is through vulnerable internet-facing web applications. So this is sort of a demonstration of that scenario. So we're going to use the well-known Kali distribution Metasploit framework, which is used as a penetration testing tool. It has scripted attacks for known CVE vulnerabilities. So again, this is publicly available. Once the vulnerable version is identified, and it could be identified through a network scan, through something like Nmap, then it's a simple lookup to see if there's a published exploit. And the Metasploit framework is there to simplify that, again, typically for penetration testing purposes. But it is also used as an attack tool. So we're going to launch the attack step by step. Then we're going to look at how the Falcon platform responds automatically and accelerates the incident response. And finally, we're going to take a look at how the Falcon platform can help you proactively improve the security in your environment. So just kind of showing you what the environment looks like. Again, we've run this kubectl get pods. We're looking at the pods running in an EKS cluster. The vulnerable Tomcat application is this one at the top, running as a deployment. You can delete that pod, but the deployment will launch a new one as expected. We use our own operator to handle the deployment of all the necessary components, including our containerized node sensor right here. And our node sensor runs in a Kubernetes environment as a daemon set. Again, this is one of the integrations that we create to accommodate the way that people operate in Kubernetes or cloud environments. Everything should be automated. When you're launching new pods, it's not a manual process. This is in response to utilization. The pods will automatically launch in response to events and conditions in the environment. And in fact, EC2 instances will also launch automatically using auto-scaling groups, cluster autoscaler, Carpenter, and so on. And all of those instances need to be protected automatically. So here, the Falcon node sensor is running as a daemon set. So each new EC2 instance that's deployed, a single pod will be deployed on that instance that protects the entire instance itself and all the containers on it. We're not using Fargate in this particular scenario, but if the customer were in this scenario was using Fargate, we would automatically inject a sidecar container to protect that specific pod on Fargate. And finally, we also deploy also as part of the operator, Kubernetes admission controller that protects the cluster as a whole, looking for misconfigurations, discovering new resources, and providing a policy engine on the back end that you can create your own rules about blocking vulnerable containers or containers with identified misconfigurations or elevated privileges. Just launching the attack, we're turning here to the Kali instance. And we're starting here, as I mentioned before, with an nmap command. And by using this -a switch, we're not only scanning this internet-facing web application, which is made available through an application load balancer over port 80, but by using that -A switch, we're able to, actually detect the version of the Tomcat container. And we see this is version 8.0.32. You can go to a public website like ExploitDB, plug in that version number, and you can see, is there a vulnerability? In fact, there is. And there's a published script to attack it that is part of the Kali distribution. It's already there. So we create a little startup.rc file right up here, which contains variables like, what is the domain name of the application load balancer, what are the ports we're going to communicate over, what is the name of the specific attack. We add that to the starting Metasploit framework, and we're off. All of the next set of commands is that automated attack. Nothing else needs to happen. You can see right here the payload. This is the name of the attack specifically, and you can see payload executed. This takes about 5 or 10 seconds. And at the end of that 5 or 10 seconds, we have shell access. So automatically, as part of the attack, we run a couple of commands. The first one, who is, and we see right here, first we connect to the session. We run this who is command. We can see we've got root access to this container. We also run a netstat to see what other ports might be listening, to see, to start our reconnaissance of that particular instance, to see how we can advance that attack. So one of the first commands we can run here, again, we have root access. We're going to do a little cat of the local etc password to see if there's any credentials there we might be able to use. Very often, people will use the same passwords across multiple instances. So if I can find it here, I can use that to move laterally toward other instances. So next thing, we're going to see what access we have in on this EC2 instance by running this instance metadata query. Instance metadata is an important feature of EC2 that enables applications running on an EC2 instance to introspect information about the instance that could be used, just in the normal operations, to get credentials, to access other AWS services, and so on. In this particular case, that particular instance, it has credentials that all I have to do is run this command, and I can see the AWS access key ID, the secret access key, and the token, and I can use this information to actually log back in, create my own credentials to create persistence. Hopefully, nobody's watching the creation of new IAM users or roles, so I can create roles and for a time, maybe evade detection and use that to move laterally in my environment. So I run a command to see what access I have running on this pod right now, and I can see that that the role that's assigned to the pod itself is just something about pod IAM S3 bucket. So, okay, maybe I've got some access on this pod specifically that's going to enable me to get access to S3. So let's take a look. So I'm going to do a search in S3, and I can see that there's a whole bunch of buckets. I did a little grep filter here because in this particular demo instance, I probably have 30 different buckets. So I know I have a couple of buckets here that are called confidential. Very often, we're very helpful in how we name these our resources. We want to give a little information so that we don't forget what they actually do. So in this particular case, we've got a bucket that has confidential information. So that's certainly helpful to keep things moving along. So now I'm going to see if this bucket is protected by bucket logging. And in fact, it is. There's a bucket policy. So as part of defense evasion, the first thing we're going to do is disable that bucket logging, which we do by creating an empty rule and then applying it, and now we've got no bucket logging. So that's very simple. And now we're going to download some attack tools to move laterally to steal additional credentials using a well-known attack tool called MemiPenguin. So we run this wget command to pull down that file. We run an ls to see that file now, like have we downloaded it? No file. Okay, now let's turn to the the Falcon console and see what actually happened here. Let's see why that command didn't succeed. Okay. Now we're on the landing page of the Falcon console. We're looking at general activity. We can see what's happening in the environment as a whole. And here in the lower right, we can see a summary of the most recent detections. So we can click right into this and see all of our detections according to a timeline. And right here at the top, we can see that wget command. If we click into it, we can now get additional detail about that command. And the first thing that we see is the process tree that shows us exactly where that command was run from. And on the right, we have our detail pane to get some of the, to get an initial glimpse of what is happening here. So, we can see that the operating system is Amazon Linux. We can see that it's running in a particular region under a specific account in AWS. Again, all of this data is critical to accelerating the incident response. So we build our service, we build our console to accelerate incident response. We build it specifically for security analysts. And we also provide information about cloud misconfiguration so we can get an idea of how the attack might have gotten that foothold in the first place, what misconfigurations might have been used to accelerate the attack. So we can get even additional detail. We can see what they're trying to achieve. Again, all the information necessary to protect the environment. And we can see what happened to the wget process. It was killed immediately. Like as soon as we saw what was happening, as soon as we positively identified that this was a malicious tool, we blocked that wget from happening. Now, in a situation where we might not have been able to detect that tool and it was downloaded and executed, our sensor that is running in the container or in an EC2 instance, as soon as an adversary tried to launch that process, we would detect that the process was trying to do something wrong that should not happen in normal operations, and we block it at that point as well. We have additional information about the host that is the EC2 instance that's hosting that container. And we can pivot right here to see how that host interacts with other resources in the AWS environment. The first thing we see is all of the detail that you might see in the EC2 configuration page. Why do we present it here? Because we have this link that we provide so that you can pivot right from our page into the AWS management page. But many security teams don't have access to the AWS resources themselves. They're confined to the CrowdStrike console and have to be able to gather their information right here. So again, accelerating that response. And if we scroll further down, one of the things that we provide is the mapping from the instance role to, from the IAM role to the instance profile. I don't know if you've ever tried to do this before. You find an instance profile, you're like, okay, what is the IAM role? There's no clear way to do that. So we provide that for you, again, to accelerate the response. And pivoting to the asset graph view of this host, we can see all of the different AWS resources that this asset, this EC2 instance, is connected to. And it's leveraging a NAT gateway. It has some NACLs, security groups, VPCs. We could see all of those connections again to understand how an attack might move laterally so that you can take action to contain it as quickly as possible. And when I hover over this instance, I can see additional information. I can see that it's online, whether it's internet connected, and I can see that there are some critical vulnerabilities and critical misconfigurations. So I can click into this and see additional detail in the side pane. And I can click into that detail to see more information about all of the vulnerabilities related to this particular host. Again, this is giving me context and awareness of how the adversary might have gotten that initial foothold and what I have to do to strengthen the security in my environment. So if I click in the vulnerabilities pane, I can see all of the vulnerabilities associated with this particular host. Now, any published vulnerability is associated with a CVE, and each CVE has a severity score. How do they come up with those scores? It has to do with maybe the potential impact that exploiting that vulnerability would have. But it doesn't consider context. And by context, we're talking about whether there are misconfigurations, whether it's internet connected, and whether there are published attacks against that particular vulnerability. And we use that information to reassess the risk of that vulnerability in your environment. We call that the expert AI rating that you can see in the second column. Now, sometimes we'll re-rate the level of risk for that vulnerability. Sometimes we'll rate it lower, and sometimes we'll rate it higher. And the reason this is important is if you know, your operations team that is patching these instances, they have a lot of things to do. You know, they're very, very busy. And they got to focus in on the things that are going to provide the most value. So we want to focus them on getting the most bang for the buck in terms of remediating the vulnerabilities where they're going to make a difference, and not just sending them on a wild goose chase to protect everything. Because, you know, let's face it, for a lot of teams, you know, after Patch Tuesday, it can take the rest of the month to get all of the instances patched. So, got to take action in the right place at the right time. Now, this is another pivot from that host view we were looking at, that detail pane, where we're looking at behavioral detections. So we looked at the specific attack that was launched against a vulnerable web app. It was picked up by a containerized sensor running as a daemon set. It was able to automatically block the attack. So our sensor doesn't just give you information or homework or something for your security team to do. When we positively identify that there's an attack in progress, we stop it automatically. And the fact that we bring in all of this contextual information means we have a low rate of false positives, because false positives are sending your security team on a wild goose chase trying to hunt down and investigate every single one. So we're already saving 75% on average of your team's time in positively identifying when there's an actual attack in progress. Now, we're looking right now at our cloud security module. So the node security, again, this is a agent-based sensor. Our cloud security, our agentless cloud security, is looking at the event stream from CloudTrail. All of the things that are happening in your AWS services are creating events that are logged in CloudTrail, and we ingest those events in near real time, looking for suspicious activity. That is our behavioral indicators of attack. So if we see something suspicious, like, well, we can create filters to look for specific information, specific attacks. In this particular case, we can see here when we disabled bucket logging on the S3 bucket. That, in and of itself, isn't going to generate a detection, but again, that's part of the context to show that something is amiss in this environment and will help create a more accurate picture of the severity and risk in your environment. Our agentless protection will also proactively scan your AWS services for misconfigurations. There's a lot of services provided by AWS, and no one person knows the security best practices for configuring those services. So as you are experimenting, as you're beginning to use different services, it's important to be constantly scanning them for misconfigurations based upon, I don't really have a lot of experience, let's say, working with this particular service, or maybe just innocent mistake. So we rate those, again, according to severity, the likelihood that they're going to be used to accelerate an attack. And this is something that teams can also use to improve the security of their environment proactively. Now, even before launching these services in your environment, we can do pre-runtime protection by scanning infrastructure as code templates, CloudFormation, Terraform, and so on, to look for these misconfigurations before they're actually running in production. Similarly, we can do pre-runtime scanning of container images, looking for vulnerable packages to prevent what we just saw in this attack. So here we're looking at the top, we're looking at a critical misconfiguration, and the 2 arrows below are the two separate misconfigurations. So we have our that IMDS v1 enabled. That was the curl command that gave us all of those credentials. And we also see that there's a high profile role associated with that, and the two together mean that this is highly exploitable, and if an adversary gains access to this, they're going to have the keys to the kingdom. So that's why we re-rate it as critical. And as I showed you before, we have the mapping to the IAM role, which we're able to look up through our cloud infrastructure entitlement management and see, is this role an administrative role, a privileged role, or is it properly scoped? So you can see at a glance if there are roles that you need to scope down the level of access to improve your least privilege. And we provide filtering in the console itself so that you can act more quickly and just sort of cut through the noise. So sort of taking the 10,000-foot view on what we just saw, our Falcon Cloud Security is comprised of multiple components. Our agent-based protection that we showed you in the node sensors, our agentless protection, cloud security posture management, and cloud infrastructure entitlement management. In that situation, it runs very lightweight. All we do when we register account is we share some cross-account roles that enable us to scan your environment, and we create event bridge rules that allow us to ingest the CloudTrail event stream. Our latest addition to our Falcon Cloud Security portfolio is the acquisition of Bionic a few months ago. Bionic provides application security posture management. So where cloud security posture management is looking at infrastructure misconfigurations and activity, on the application side, we're looking at the specific access between your microservices, your application environment, and the data sources themselves. So we're able to automatically detect whether the data is sensitive data just based upon who's accessing it, what services are making use of that data, and we can see whether there's authentication on the APIs themselves, and so on. The way that we do that is we look at the actual compiled code. We reverse engineer that to see all of the connections between your services and your data sources, and we can create a map to find the risks in your environment. While cloud security posture management provides a lot of insight and protection in your cloud infrastructure environment, it's important to also have this additional layer because the rate of change in your application environment is about 100 times more. People move to cloud to accelerate the rate of innovation, which is great. But it also makes it a lot easier to insert new vulnerabilities and misconfigurations into your application layer environment. And when you're releasing multiple times a day, now you're looking at like a huge amount of change that you need an additional insights to stay on top of, to understand your risk posture. Bionic is agentless. There's no installation. You associate it with your with the code itself. We don't have to look at source code. We're able to look at the binaries themselves. And it, again, simplifies identifying the top business risks. Just one example of how we help a well-known travel operator moving toward a microservices environment. We were interviewing them about the protection of their API environment. We ran our application mapping scan, and we found an API that was internet facing, and there was no authorization, no API key required. And this particular microservice was specifically for gathering customer personal data. So we said to the CISO, we said, oh, by the way, did you know that you have this internet-facing API? And they're like, no, not possible. So we're like, well, it's right here. So this is the map that we created. You can see that map of different microservices and their associated data stores. And this one right here in the corner hit that threshold of that 100 score that showed just critical severity. We're like, here it is. And they took a look at it, and they're like, hey, you're right. This was a mistake. This is just something that a new developer had made this change, and it got past our code review. So, again, having that ability to see what's happening, mapping out all of your application dependencies, again, gives you the visibility to be able to protect your environment, because you can't protect what you're not aware of. So some key recommendations to defend your cloud environment. Basic cloud hygiene, again, discovery. Make sure that you're aware of all your new resources. Again, cloud security posture management, we do that. Prioritizing identity, making sure you're using the principle of least privilege. And endpoint to cloud protection. So you can protect your cloud environment, but you have resources in an on-prem environment. You're using workstations. You have servers maybe in a data center or on-prem. Many attacks that we see start from a developer or operations staff laptop, again, through a phishing attack or the like, and use the access from that laptop, the credentials that might be stored in that laptop, to access the cloud environment. So you want to cover your entire environment. You want to correlate telemetry, security events across all of your environments together, so you don't fall into that siloed security data problem. I mentioned before, by consolidating from multiple consoles, from multiple agents into a single console, and we provide that comprehensive visibility and data to accelerate incident response. We see on average here 74% accelerated cloud detection and response. 780 hours saved by adopting Falcon Cloud Security and not having to respond to every single new false positive, and saving a lot of money, because operating all of these multiple tools is costly, in addition to not being quite as effective. At the end of the day, it's all about effectiveness. We have analyst reviews. We find ourselves in the leadership quadrant. We have third-party testing. SE Labs, an independent testing firm, rated us at 100% ransomware protection, if any of you are concerned about ransomware. It's very easy to take next steps. If you're not already a customer, you could learn more about the platform. You can download our Cloud Risk Report, Global Threat Report, our Threat Hunting Report. If you'd like to try out Falcon Cloud Security. If you'd like to even assess what your level of risk is in your current cloud environment, you can sign up for the Cloud Security Challenge. Very simple. We deploy Cloud Security Posture Management, give you a score of the risks and vulnerabilities, severity inside of your cloud environment. And we provide $1,000 of AWS service credit just for participating, no obligation. Easy way to get started. And if you'd like to get hands-on with the Falcon platform and our different products, we have a hands-on lab every single Wednesday. You can go to this site and sign up and get hands-on and try it out for yourself. Before you leave, please fill out the session survey, and I have some time for questions.